Hi there, Mr. Holcomb here with another episode of The Math Behind the Module. Okay, this is lesson 19, writing, evaluating, and finding equivalent expressions with rational numbers. This class began with the classwork. It was your traditional tic-tac-toe, and what students were required to do was pick any one of these they wanted, any one of these expressions, and put them into the tic-tac-toe locations. Order did not matter. So I will just pick some of these. So I'll pick this one, and I'll put 4x minus 12 here. I'll put this one, negative 4x plus 4. About this one, 8x plus 4 minus 12x. And 3x minus 2, 4x minus 4. X minus 2 plus 2x minus 4. 12 minus 6x plus 2x used. 12 minus 4x. So that one's used. And I will use this one here. I'll avoid the decimals. 8x, or 8 times the quantity 1/2 x minus 2. Okay, so then once that is done, what I did in the class was I pasted in the teacher list as such. Let me shrink this down a little bit so we can see it over here. So this was the teacher list I gave them in class. So what they were supposed to do was rearrange or find a way to represent these expressions here and find the equivalent expression here. So in order to do that, we can look at the first one here, 2x plus 2 times the quantity x minus 6. Well, this is the distributive property here, so I can leave that 2x plus 2x, and then distribute 2 times negative 6 would be negative 12. So I have 2x plus 2x minus 12. And I'm looking around here and I don't see it anywhere, but then I can see that this 2x plus 2x can be combined to 4x. So that would end up being 4x minus 12. And 4x minus 12 is right here, so I put an x. So I had the first on the teacher list, and it was located right here, 4x minus 12. In 4x minus 16, there's nothing to combine, but we can work backwards. We can factor out a 4. And if I divide 4x by 4, I simply get x. And if I divide 16 by 4, I get 4. So it's 4 times the quantity x minus 4, and that is right here. And we did this until a student would get a tic-tac-toe, and then I asked at the end if anybody had tic-tac-toes. Several did, a few didn't. Okay, now if I distribute this, 1 times anything is just that anything, so we have x plus 2. If I distribute this, I get 2x. If I distribute here, 2 times negative 2 is minus 4. So I have x plus 2 plus 2x minus 4. So I have x minus 2 plus 2x minus 4. So there's a problem right there. Let me make sure I didn't copy it down. And that is a minus 2. Okay, so there might be an error in this. I believe there was. So x plus 2x is 3x minus 2. So that could also be represented as 3x minus 2, because I said x plus 2x is 3x. 2 minus 4 is negative 2, so I have 3x minus 2. And I don't see that anywhere here either. This is not the same. This is 3x minus 6 if you distribute. Okay, so there was a problem with this here, and I think something to do with the sign. So in order to find one that said x minus 2 right here, this should have been a minus sign in the teacher list. So there was a misprint, I believe, in the teacher list. Okay, so 4 times 3 minus x, if I distribute this, 4 times 3 is 12. Positive times a negative is a negative. 4 times x is 4x. That's 12 minus 4x. 12 minus 4x is right here, so I still don't have a tic-tac-toe, so I continue. 4 times 2x is 8x. 4 times 1 is 4, minus 12x. So I have 8x plus 4 minus 12x. Okay, so 8x plus 4 minus 12x is right here, so I would have x there. And then finally 3x minus 6, well, if 3 will go into 3, 3 will go into 6, so that's a factor. And I divide and I get x minus 2. So 3x divided by 3 is x. And negative 6 divided by 3 is negative 2. So I have 3 times x minus 2, which is right here. So now I have 2 here, but I'm missing this here. I'm missing that here. I don't have this. I don't have this. So is there another way I can represent some of the things I already have? So erase. All my work before I get it out of the way. Let's take another closer look at this. Alright, so let's look at the O's. Negative 4x plus 4. So anywhere in here I can get that. No. Okay, I don't see anywhere that we would use a negative 4x plus 4. So if they didn't choose this, this would be 4x, and then this would be minus 12. So at this point, it doesn't look like 12 minus 6x plus 2 can be written as 12 minus 4x. It's 12 minus 6x plus 2x. Negative 6x plus 2x is 4x. Okay, that's not an integer list. But once I do this, I can factor out a 4. Get 3 minus x. So this is just a lesson on showing multiple ways something is represented. And once I did this, so this 12 minus 6x plus 2x, if I combine the like terms, negative 6x plus 2x, I got negative 4x, and saw that 4 and 12 factors of 4 will come out. I end up with 12 divided by 4 is 3, and negative 4 divided by 4 is a negative 1, and 4 times the quantity negative 3 minus x, and that is right here. So now I can turn that O into an x, and I have a 10. Okay. So, example 2 says we have an original price, 100%. So if you're paying full price, you're paying 100%. A discount amount, and a new price to pay 80%. And what would be the expression to represent that? Okay. So if I want to discount $100, the original price of 100%, say something costs $100. I want to discount it 20% off. Then I would take that original price, multiply it by 0.20, because 20% means 20 out of 100. So 20% can be represented as 20/100ths. Okay? And the zeros cancel, and we have 2/10ths. But if I show it as 20/100ths, 20/10ths, hundredths, means 0.20. Okay, so it just moves the decimal just 2 places to the left. And when I multiply 100 times 0.20, I get 20. So if I do the same down here, the original price times 0.20 equals 5 times 2 is 10. Then it moves the decimal one place. 28 times 0.20 is 28 times 2, 56. And then you move the decimal one place, $5.60 in this case. Continuing down, $14.50 times 0.20. Okay, so now I'm going to show this one this way, 14.50 times 0.20. Put the 0 here, 0. 5 times 2 is 10, 4 times 2 is 8, plus 1 is 9, 2 times 1 is 2. Okay, 1, 2, 3, 4, 1, 2, 3, 4 decimal places. Okay, so we started here. We have 2 decimal places from the 0.20, 2 decimal places from the 0.50, totaling 4 decimal places. So instead of putting the decimal here, we go 1, 2, 3, 4, and this is $2.90. So now we're going to do it as an example with variable. X being any amount, all we have to do is multiply the whole price, the original price, 0.20, and that is going to be 0.20x. Okay, next thing we're going to do is the new price is the same as saying paying 80%. If we are going to get a discount of 20%, then we're going to pay 80% of the original price, because the discount 20% plus the new price 80% is going to total the original price 100. 20 plus 80 is 100. So instead of multiplying the original price defining the discount, now we can take the original price, $100, and multiply it by what we're going to pay, which is 0.80. And this way we can find out what our new price is going to be, rather than finding the discount and having to subtract. So here I found the discount. In order to get the answer now, I'd have to take $100 minus 20 and get $80, which is the same thing as 100 times 0.80, which is 80. Okay, so we can actually find how much we're going to pay in one step, rather than finding the discount and subtracting from the original. So we take $50 times 0.80, and 5 times 8 is 40. It's $40. Okay, and we can also represent this as a subtraction, like I said before. If I take the original price, $100, and I subtract the discount 20, then I also get 80. And let's just use this column. So this would be the original price minus the discount equals what we're going to pay. Original price minus discount. 28 minus 5 is 23, so it's going to be a little bit less, 22, and it's going to be 40. Okay. Original price $14.50 minus our discount of $2.90 equals. Now it's easy to do mental math here. We're only 10 cents away from $3. So $14.50 minus $3 is $11.50. We want to take $3 off. We want to take 90 cents. We have to add 10 to that. $11.50. So it's going to turn into $11.60. So we have 10 cents less than $3. And then finally, on the last one, to have a formula, we take the original price minus our discount, 0.20x. That's going to equal 0.80x. Okay? So now we're going to write an expression for all of this. So for the first one, I'm going to say 100 minus 100 times 20. Okay, 100 minus 100 times 20. So it's the original price minus the discount. And then we can distribute. Okay, factor out a 100 in other words. So I can factor out a 100, and 100 divided by 100 is going to sign here. 100 times 0.20, or 100 times 20. That should be a 0.20, by the way, discount. So 100 divided by 100 is 1 times 0.20, which is just simply 0.20. Which comes out to be 100. 1 minus 0.20. This may be a little confusing at first, but all we are doing is factoring. We're starting to factor. We're starting to do the distributive property, which is factoring the direction. So in this case, we want our expression to be our original price minus our discount, which was 50, original price, times 0.20. This has a value of 50. This has a value of 50 here, so we can do what's called factoring out like terms. This has a 50, and that has a 50, so I can take it out of each. So 50 divided by 50 is 1. Bring down the minus sign. 50 divided by 50 is 1 times 0.20. But we aren't necessarily concerned with that 1 there, because anything times 1 is itself. So that's why we don't show that minus 1 there. We would just simply write. So 50 times 1 minus 0.20 is 50 times. This one, the original price was $28 minus $28 times the discount, 20. Factor 28 divided by 20, 1, minus 28 divided by 20 is 1 times 0.20 is just 0.20. And then 28, 1 minus 0.20 is 0.20. $14.50 minus that $14.50 times the discount of 20%. Distributive property, or factoring I should say, we're going the other way. Factor out of 1450. 1450 divided by 1450 is 1. Here we have to write the 1, so we put nothing. That just means 0, so 1450 times 0 is not 1450. We have to have a 1 there. Minus 1 times 0.20, which is 1. Simplify by doing the operation in the parentheses. Okay, and then finally we have the original price minus the original price times 0.20. Factor out an x. X divided by x is 1. X divided by x is 1 times 0.20, which is just 1 minus 0.20 is 0.20. And now finish this table. Getting a little bit of practice of distribution. Okay, example 3. An item has an original price of X dollars and is discounted 33%. Write an expression that represents the amount of the discount. Okay, what would represent that discount? Well, that's just simply a decimal point. So 30 times however much the original price was. So it's 1/3 of some value X. Okay. Write 2 equivalent expressions that represent the new discounted price. 2 equivalent expressions, there's multiple ways we can do this. One way is take the original, going back to our table we just did, take the original price minus that 0.33x, which was the discount. And then just do what we did in our table and factor 1 minus 3, which would represent as 67 times x. Okay, so these are actually, this is 3 equivalent expressions, 2.33x. To represent the discounted price. So we can take the original minus the discounted price, or the original times 1 minus the discount, or the original times what's left over. C says to use one of your expressions to calculate the new discounted price if the original price was 56. I will just use the last one. And so this is my x. 56 is x. So I'm going to put 56 here times 0.67 equals, and that comes out to be, well, I'll show the word. They already have done it. The problem with showing 7 times 6 is 42, bring your 4 up here. 7 times 5 is 35, plus 4 is 39. Don't forget your spacer here, I still have a few who don't do this. 6 times 6 is 36. 6 times 5 is 30, plus 3 is 33. Add your 2 columns or rows. 2 plus 0 is 2, 9 plus 6 is 15. Carrier 1. 3 and 3 is 6, plus 1 is 7. And 3, I have 2 decimal places and no decimal places. So I have 2 decimal places. The answer is $37.52. That's the discount. D says, how would the expressions you created in parts A and B have changed if the item's price had increased by 33 cents instead of 33% instead of decreased by 43%? So say they were running a special, and then they said, okay, this special's over, we're increasing the price by 33%. What would it look like? Instead of subtracting 0.33x, so if we look back up here, we're looking at this right here. This is a discount from the original price. We are not going to subtract, we're going to add. So it's going to be x plus 0.33 of that price. And this is a 1. This is 0.33x. So 1.00 plus 0.33 is 1.33. So 1x plus 0.33x is 1.33x. That would be our numbers. Okay, example 4. I did not do this in class because it was rotated sideways, so give me a moment and I'll rotate it. Okay, I lost a little bit of resolution with this, but it's better than sideways. Okay, so here we're going to fill out this example. And it says the original price of $150. So now new price, sales tax 8%, overall cost of expression. So this is what we've already done on the prior page. Now we're just expanding it out. So the new price, the amount to pay is the new price. So all we're doing is copying this over to the price. So this is going to be 80, 40, 22.40, $2.90. Oh, not too far that time. $2.90, $11.60. And 0.80x. Sales tax is 8%. So we want to add 8% to 80, so it's going to be 80 times 0.08. Be careful, 8% is 0.08. 8 times 8 is 64. Or 8 times 80 is 640. Two decimal places, put $6.40. Overall cost would now be the new price plus the tax. Here in Italy, they've already included tax in the price, so what you see in the price tag is what you pay at the register. That costs, in this case, $86. This one here is going to be 40 times 0.08. 8 times 40 is 320. We have 2 decimal places, so it's $3.20. So it's 40 plus 320, which is 43.20. 22.40 times 0.08. 8 times 0 is 0. 8 times 4 is 32. 8 times 2 is 16, plus 3 is 19. 8 times 2 is 16, plus 1 is 17. 1, 2, 3, 4 decimal places. And that would be $1.79. Okay, so be careful with your decimal place there. It would not be $17.92 tax on 22. That'd be a huge amount of tax. So it's $1.79. And we're just going to round down that from 22 just $1.70. So I'm going to now write 22.40 plus $1.79. Get our new price. 9, 1, 4, $24.19. 11.60 times 0.08. 8 times 0, 0. 8 times 6, 48. that 4. 8 times 1 is 8, plus 4 is 12. Don't forget the 1. 8 times 1 is 8, plus 1 is 9. And I have 1, 2, 3, 4 decimal places. 1, 2, 3, 4. Again, it's only $11, so to pay more, $9 tax would be ridiculous. So think about what you are doing. And all this is saying is this 0.80, we need to round up, so I would round that up to 93 cents. So this is going to be $11.60 for the discounted item, 93 cents tax, and totaling out to be $25. So I made a mistake. Try that again. 0 plus 3, 9 plus 6, carry the 1, 2, 1, $12.53. Okay? And on the last one, what we're going to do is take 0.80x times 0.8. So when we're multiplying a number times, this is called a coefficient from a variable, you just multiply the numbers and the x is going to stay there. So it's 8 times 0 is 0. 8 times 8 is 64. And I have 1, 2, 3, 4 decimal places. So it's 1, 2, 3, 4 decimal places. So my answer is going to be 0.8x plus 0.064x. Okay, let me rewrite that as a little less. My decimals didn't line up. Okay, so we have our original, or our new price, 0.80x, and I'm going to add 0.0640x. Okay, and I want to be really careful with this. I have to line up the x's. See if I can erase that. Alright, so this x should be right here, so it's going to end up with just bringing down the x when we're adding. We don't change the exponent or the variable, the number. The only thing that changes is the coefficient, which is the number. So now this 0, I should have another 0 here because I have a decimal place here. So the 8, 0 line up, the 0, 6 line up. I should have a 0 here and a 0 here. 0.8000x is the same as 0.8x, doesn't have the zeros. So 0 plus 0 is 0. 0 plus 4 is 4. 0 plus 6 is 8 plus 0. And that's my answer. 8640x. Okay? And the expression, it was just the distributed property. I'm going to do one, but I'm not going to do every separate. So what we're going to do is we're going to take our original price, $100, minus our discount, which is this here. Plus 0.08x, the tax, x there. So it's 0.08 times 1 minus times 0.20. Okay, so where am I getting all this here? All I did here was this here was distributed because this one was already done. We had already factored out a 100 here, so I just copied this piece. And then we have this 100 times 0.80. So I'm going to factor out a point, or I'm going to take the tax, 0.08, I'm going to add it to 100, that should be 100 right here, 100 minus 100 times 0.20, okay, which is 0.8. Okay, an easier way to do this, let me do it in a different way. Maybe that was confusing for you. We take that dollar 1.08. So what we're doing here now is just taking the 100%, okay, and we're adding the tax, which is 0.08. So 100% is 1 plus 0.08 is 1.08. Multiply that by the original price minus the original price times the discount. Okay, or we can even make it a little bit easier and just take the $8 on 100% cost of what we're paying times 8% tax per 0.08 and multiply it by what we're going to pay, which is right here. So 100 times 0.8 or times 80. That's probably the easiest way to do it right here. So just take $8 times 80% of what your original price was, because that's what we paid. So $8 times. Okay. So in this one here, I'll do one more. It'd be 108, 100% plus the 8% tax, times the original price of $50 times 0.8, 80% of $50, and so on and so on and so on. Okay, that's the end of this lesson. Hope we get problems.